Okay, so for algebra, we have a couple of major things we need to deal with. We need to deal with our exponentials, our exponents, our logarithms, fraction manipulation, and then all of the properties that go with those. So let's start by thinking about two different things real quick. So one is where we have an exponential, where we have a constant a to the power x, right? So something that might look like would be 2 to the x, right? That's an example of that. Another thing we might have is some constant times a variable to some power, right? So that might look like 2 times x to the third, right? That's what that could look like as well. Okay, so there's some properties that we have that go with these. We want to make sure we're paying a lot of attention to make sure we have as much simplification as possible within our problems. So one of our properties is when we have anything to the 0 power. So a to the 0 equals x to the 0, which those all equal 1, right? So that is a property of exponents. Anything to the 0 power is going to be 1. And that includes 0 to the 0 power is still 1, right? This is also part of why 0 factorial is equal to 1, but that's not what we're going over right now, so we won't worry about it. The next thing that we're going to look at is negative powers. So if I have a to the negative 1, for example, or we'll call it negative x, what we can do here is we can say, okay, well, a negative exponential actually flips the entire term to the bottom. So in this case, this becomes 1 over a to the x. Now, we also need to take into account our other guy here, our cx of n. So let's say we had c x to the negative, we'll call it y. How about that? So in this case, the c stays on top because it is not distributed with this power. This is just distributing here. So it's c over x to the y, right? And this is something I see people mess up a lot, especially on like requisite tests or stuff like that. This is a very easy mistake to make. Okay. The next one we should go over is a fractional exponent. So if you have a to the x over y, so the divisor on a fraction in your exponent is going to be equivalent to some sort of root. So this is the y-th root of a to the x. So the way we'd write that is y root of ax, right? And that's how that one works. Also we have a to the x to the y, right? This actually turns out to be just a xy. So we can just pull that outside one inside. So that one's not too bad. But that is not going to be the same as when you have ax times ay, because that is where you have addition of your exponents. So in this case, you'll have ax plus y. And similarly, if you have ax divided by ay, that becomes ax, and then you're going to multiply it by a to the negative y, which now you can see using that before property, that becomes ax minus y, right? Okay, so those are all the exponential properties. Let's see if we can dig up an example or two for those, and then we'll look at our logarithm properties. So I do have a few examples here. This first one will be pretty straightforward. So this is going to be 3 to the 6th power divided by 3 to the 2nd power. Now in this case, we're going to do what we did here. We're going to flip it up and then subtract the powers. So we're going to turn this into 3 to the 6th times 3 to the negative 2, which is then going to become 3 to the 6 minus 2, which is 3 to the 4th. 3 to the 4th is 27 times 3 is 81, I think. Something like that. But not important. So this is how the exponents can go from something a little annoying to plug into your calculator or even straight up confusing to something a lot more straightforward. And this works for bases as well. So sometimes you'll have, for example, 8.85 times 10 to the negative 9 and that'll be multiplied by, I don't know, speed of light maybe, 3.6 times 10 to the 8th, and then divided by 6.602 times 10 to the negative 19, something like that. Why not? Didn't matter. So typing this into your calculator leaves a lot of room for error. So what we can do instead is just simplify our exponents first. This is all addition and division, so we can simplify these exponents. So the easiest way to do that is bring this one on top and then add them all together. So you'll take your 8.85 times 3.6 divided by 6.602, and then you'll just multiply that by the addition of all of these exponents over here. So you have 10 to the negative 9, and then plus 8, right? And then when you flip this negative 19 up, it becomes positive 19 to get plus 19. Okay? So in this case, this becomes these same three numbers times 10. Negative 9 and 19 is 10, plus 8 is 18, 10 to the 18th. So you've just reduced the possibility of you making mistakes significantly, because now you don't even need to put that in the calculator, you just need to put this in. And then you just write this at the end, or adjust it if you need to get it into scientific notation. So it's super useful to really understand these. Makes your life a lot easier in all of your engineering courses, not just calculus. Okay, let's do one more example. This one's a little bit more tricky. So we've got 4 times, and I'm using parentheses very carefully here so it's very clear what I'm trying to do. 2a in parentheses squared, that's going to be multiplied by 2x to the negative a, and all of that is divided by 4 to the 1/2 power times x to the a. Okay? So, a lot of things to do here. This is probably one of the more complicated versions of this problem. So let's deal with all these constants first, and at the same time I'll bring this a down. Okay, 4 and 2, 8, right? Nice and easy. 8 times, and I'm just rewriting this part, I'm not changing anything yet. Divided by, now x to the a, and then this becomes x to the positive a down here, so you have x to the a plus a, which is x to the 2a. Okay, now 4 to the 1/2, remember, a divided power is the same as a root, so root 2 is also known as a square root, so the square root of 4 is just 2. Okay, well that's where we're at now. Okay, so let's deal with these constants. So we get 4. And now let's see, what can we do with power and power? Well, if we remember, power to the power is going to be multiplied, right? So instead of x to the 2a, we're going to get x to the 2a times 2, right? And then we can divide that by x to the 2a. Well, let's go ahead and bring this guy up and then do this multiplication at the same time. So we have equals 4, and then we're going to have x to the 4a times x to the negative 2a, which we know we can just use our subtraction of exponents on now, and we get 4 of x to the 2a. There you go. Something pretty gnarly, something pretty